All right, let's dive into Proxmox. In this explainer, we're going to go from zero to hero. We're going to take all those separate individual hosts you might have running and forge them into one powerful, unified cluster that you can control from a single screen. Sound good? Let's get started. So if you're running more than one Proxmox server, you totally know the drill, right? You're constantly jumping between browser tabs, logging into different web interfaces just to manage your VMs and containers. Well, it's a pain. It's inefficient, it's a headache. But what if I told you there's a much, much better way? Well, guess what? There is. And that's exactly what we're here to do. Together, we're going to walk through the whole process, step by step. We're going to take those lonely, isolated hosts and turn them into a single, fully functional cluster that you manage from just one place. All right, let's do this. Okay, so here's our game plan. First, we'll unify our hosts with clustering. Then we'll build out the network backbone. After that, we'll master Proxmox routing, expand with some network storage, and finally, we'll wrap up with a handy troubleshooting guide. Let's get to it. All right, first things first, clustering. This is really the secret sauce. It's what brings all your Proxmox servers together under one roof, giving you that single pane of glass to manage, well, literally everything from just one login. This is the foundation that unlocks the cool stuff, like live VM migration. And you know what? The process is actually super simple. Seriously, you just pick one server to be your main node, click Create Cluster, and it spits out this special join key. Then you just hop over to your other nodes, paste in that key, and bam, they've joined the party. As long as they can see each other on the network, they'll all just show up right there in your data center view. Easy peasy. Okay, so our hosts are all friends now, living in one happy cluster. The next logical step is to build a network that they can all share, for our virtual machines. This is where we get into the really cool part, configuring Linux bridges and VLANs. This is how we'll keep all our network traffic organized and secure. Now, if you're coming over from the VMware world, this slide is for you. It's basically a little translation guide. What you're used to calling a vSwitch, in Proxmox, that's just a Linux bridge. And those port groups you use for VLANs, Proxmox does it a bit more directly. You just tag the VLAN right on the bridge itself. It's the same idea, just, a different way of getting there. So let's get down to it. What exactly is a Linux bridge, this VMBR thing? The easiest way to think about it is like a virtual network switch that lives right inside your Proxmox host. It grabs a physical network port, your Eno1 for example, and then lets you plug all your virtual machines into it. And the really powerful part is that this one bridge can juggle multiple VLANs all through that single physical cable. Pretty neat, huh? Okay, let's get our hands dirty and actually set this up. First, you'll create a new Linux bridge. We'll call it VMBR1, and you'll tie it to a physical network card. Now, right here, you've got a choice. The simple path is to just check the VLAN aware box on the bridge. Or, if you want more control, you can create these little sub-interfaces for every single VLAN. Either way, once your bridge is ready, you just go to your VM settings, attach it to VMBR1, and then pop in the VLAN tag number you want. That's it. Proxmox takes care of the rest. So, we've got our cluster, we've got our neat, tidy networks all separated by VLANs. Awesome. But how does a VM on one VLAN talk to a VM on another? Or how do any of them get out to the internet? Well, that's where routing comes into play. Think of it like a GPS for your data. So yeah, how does Proxmox know where to send all this traffic? It's not magic. A VM can't just shout into the void and hope its data gets to the right place. It needs directions. It needs a map. And in the world of networking, that map is called the routing table. And here's what that map looks like. When you run the command ip_route_show, this is what you get. Let's break it down. That default line, that's your main exit to the internet. It's the catch-all. If Proxmox doesn't know where something goes, it sends it to that gateway address on VMBR0. The second line is simpler. It's saying, hey, for anything on the 9.70.4.0 network, I'm connected directly to that on VMBR1. No need for a gateway? I know right where it is. Okay, but what happens when you need to talk to a network that isn't local and isn't out on the internet through your default gateway? This is where you have to give Proxmox some specific instructions by adding a static route. And here's the crucial part. To make sure that route doesn't just vanish the next time you reboot the server, you have to add this line right into your network configuration file. That little up command at the beginning tells the system, hey, every time this network interface starts up, make sure you add this route. It makes it permanent. Our cluster is looking pretty sweet, but to really unlock its true power, we need shared storage. By hooking up a NAS, a network-attached storage device, we create a central library for everything: our VM desks, our ISO images, our backups. This isn't just for organization. It is absolutely critical for the really advanced features, like high availability and moving a running VM from one host to another.
So you've got a few main options when it comes to network storage. You've got NFS and CIFS, which are what we call file level. Think of these like a shared folder on the network, great for storing ISO files and backups. But then you have ISCSI. That one's different. It's block level, which is a fancy way of saying Proxmox thinks it's a raw hard drive plugged directly into the machine. It's a bit more direct, which makes an amazing choice for your high-performance VM disks.
And the good news is, adding something like an NFS share is ridiculously easy. It's all done right from the Proxmox web interface. You just pop over to Data Center, then Storage, and click Add NFS. From there, you just fill in the blanks, give it a name, punch in the IP address of your NAS and the path to the share, and then just tick the boxes for what you want to store there. Disks, ISOs, backups. Click Add, and you're good to go. It's that fast. Okay, the build is complete. But we all know that in the real world, things don't always work perfectly. Things break. So in this last section, we're going to put on our detective hats and become troubleshooters. We'll tackle some of the most common and, frankly, most annoying network problems you're likely to run into. Okay, let's start with an absolute classic. We've all been there. You go to ping a machine, that first reply comes back instantly, and then nothing. Timeout, timeout, timeout. It is one of the most maddening things to see. So what in the world is actually happening? 9 times out of 10, this is an ARP issue, and it's almost always caused by 2 devices on your network having the same IP address. Here's the play-by-play. Your computer sends out a broadcast, an ARP request, basically yelling, "Hey, who has this IP address?" The correct machine answers first, so your first ping works. But then the imposter machine with the same IP might answer, and your computer gets confused. Its ARP table gets messed up, and it starts sending the rest of your pings to the wrong place, basically into a black hole. The fix? You either gotta hunt down that duplicate IP, or you can give your computer a little amnesia by clearing its ARP cache for that specific IP. All right, next up is another one of those weird network messages that can be confusing. ICMP redirect. Now, it sounds like an error, right? But it's actually not. It's your router trying to be helpful. It's basically tapping your server on the shoulder and saying, "Psst, there's a better way to get there." But the fact that it's having to do that usually means something's not quite right in your setup. So yeah, an ICMP redirect is just a router seeing your traffic go the long way around and telling your Proxmox host, "Hey, you don't have to send that through me. There's a much more direct path." This almost always means your routing table has some kind of overlap or ambiguity. The solution is to go back to that IP route show command, take a hard look at your routes, and then add a more specific static route to clear up any confusion and force the traffic down the right path. And for our final tip, this one is a big one. A huge percentage of "why can't I connect" problems come down to the built-in Proxmox firewall. See, by default, its policy for incoming traffic is set to drop. That means it's like a bouncer at a club with a very strict list. If you're not on the list, you're not getting in. It blocks everything by default. So if you can't even ping your host or you can't get to the web page, this should be the first place you look. For troubleshooting, you can temporarily set it to accept, which is like an open door policy. But for security, the better long-term fix is to keep it on drop and just create specific rules for the traffic you want to let in. And just like that, we're done. Look at what you've built. We started with a bunch of separate standalone servers, and now you have a fully integrated, powerful cluster. It's got advanced networking, shared storage, and, best of all, you now have the skills to troubleshoot it when things get weird. That is a seriously capable system you've put together. So there's really only one question left to ask. Now that you have this awesome, powerful Proxmox cluster ready to go, what are you going to virtualize first? What cool project are you going to spin up? Thanks for building this with me.